So we're just going to do a bunch of examples so that we can get a good feeling for working with derivatives. So we're going to look at z equal to f of xy, or f of xy equal to a polynomial 5x squared minus 2xy plus 3y squared. And I just want to compute all the sorts of partial derivatives that we might care about. So dz dx, partial derivative of z with respect to x. What I want to do is I want to take the derivative with respect to x of what z is. 5x squared minus 2xy plus 3y squared. And when I do this, what I'm trying to take derivatives of are things that depend on x. So what helps me to think is that y may as well be constant. I know it's another letter, so we're used to treating it like a variable, but as far as x is concerned, y could be the number 7. So this partial derivative is going to be 10x, 5x squared becomes 10x, minus 2y. And since this is our first time taking partial derivatives, I'm just going to show you that you can think about it the same way as if y was just a number and you had something that only depended on x, and you took the regular derivative with respect to x. You would get 5x squared becomes 10x. This thing in the middle would become whatever constants you had before. So minus 2 times 7 times x became 1. And then this thing at the end would just become 0. So if you knew how to take that derivative, when you're taking a partial derivative, just pretend like your y's or your x's, whichever variable you're currently ignoring, are constants. You see, this is the same as my 10x minus 2y. So I'm just going to write right here that you can compare to that. You don't actually have to do that, just that's kind of how we're approaching it. And then that's going to be the same as f sub x. Again, that's just that difference in notation. If I want to take the partial derivative with respect to y, I'm going to look at this whole 5x squared minus 2xy plus 3y squared, and I'm just going to pretend x is a constant. The partial derivative of 5x squared with respect to y is 0. X isn't y, so this may as well be any number. And when you take a derivative of a constant number with respect to a variable, you get 0. Minus 2xy just becomes minus 2x. Our y drops out. And then our plus 3y squared is just plus 6y. And the way to denote that derivative would just be as f sub y. And so I'm going to go ahead and take our second derivatives too. So there's how we denote the second derivative of z with respect to x, or we could write it f sub xx. And this thing I'm doing after every time I write the partial derivative I want, where I pull the d dx out and kind of show it to you, that's just an intermediate step for you to see what I'm doing. I'm communicating, I want to take a derivative with respect to x of all this stuff. That's not something I need you to be showing me all the time, and I probably won't always show that much work. This is just something I'm trying to do right now while it's unfamiliar to us, to be really deliberate so that when you go back over your notes, you can see what we were doing. So taking partial derivative with respect to x of the derivative of z with respect to x, that'll get me to the second derivative with respect to x. So d dx of 10x minus 2y. So derivative with respect to x of 10x is just 10. Derivative with respect to x of minus 2y is 0. Because minus 2y may as well be a constant as far as x is concerned. I'm going to keep repeating that during this first lesson on derivatives. It'll become second nature for you all later, but we should just be very deliberate this first couple times. All right, so now I want to take the second derivative of z with respect to y. That's indicated by f sub yy. I'm taking the derivative with respect to y of the derivative of z with respect to y. So I got 10x minus, 2 minus 2x plus 6y before. So derivative with respect to y of minus 2x is 0. X doesn't depend on y. The derivative with respect to y of plus 6y is just plus 6. And so that is showing us these single derivatives we talked about, and also these first couple second derivatives that are sort of like you're used to being able to take y, y double prime, so on and so forth. This is kind of like z prime, z double prime. But we also learned about our mixed partial derivatives. Those were, we could take d2z dy dx or d2z dx dy. And so real quick, I'm going to just copy over my z again. 5x squared minus 2xy plus 3y squared. Plus 3y squared. And so my dz dx was 10x minus 2y. My dz dy was minus 2x plus 6y. Let's make sure I didn't make any silly mistakes. 10x minus 2y minus 2x plus 6y. Awesome. So these mixed partial derivatives, I told you, we'll do that one first. dy dx is going to be, we take the derivative with respect to x first and then with respect to y. And that's the same as f sub xy. So that's the same as having d dy of dz dx. Or we also write it f sub xy. That's the same as having f sub x, and then we take a derivative with respect to y. Seeing it those two different ways might help you remember why the order is opposite. If it doesn't, that's okay. But I'm just going to follow the rules here. d2z dy dx means take a derivative with respect to x. I did that right here. And then a derivative with respect to y. So I want to take the derivative with respect to y of 10x minus 2y. That was my dz dx before. So I just put it right there. Derivative of 10x with respect to y is just 0. Derivative of minus 2y with respect to y is just minus 2. And we can do the opposite. d2z dx dy is the opposite order. So I'm going to want to take the derivative with respect to x of dz dy. Or I would also write this f sub yx, because I'm going to start with f sub y, the derivative with respect to y, and I'm going to take a derivative with respect to x. So I want to take the derivative with respect to x of dz dy, which I found to be minus 2x plus 6y. So the derivative of minus 2x with respect to x is minus 2, and the derivative of 6y with respect to x is just 0. And I want you to notice that these two things are the same. I got minus 2 here and minus 2 here. And so for some functions, the order of these mixed partial derivatives will matter, but pretty much every function you'll encounter in this class, that's not going to be the case. So it's important that you understand the order that this is happening here, but it's really not going to affect your answers. If I've been going more than 5 minutes, I'll stop there. Yep. Okay. So that's our example with derivatives. Hopefully you feel good about those.